Okay, let's try a few questions. The first one, the FAR is 3.5. The site is 100 by 100. How big a building can you build on the site, and how many floors is it? So we have 100 by 100, and that means that our overall site area is going to be 10,000 square feet, and we have an FAR of 3.5, which means we can build in terms of square footage of the building. Now, typically, it might be different in certain locations, but typically when you talk about FAR, you're not talking about basement floor. So you're just talking about the floor area of the building that is above ground. What defines what's in a basement and what's above ground, that's a little different in different locations, but the gist of it is we're talking about above grade. So if we have an FAR of 3.5, that means we have a floor area ratio, which is saying that the floor area is in a ratio with the site area of 3.5. So if we have 10,000 square feet of area on the site, that means we have potentially floor area that we're allowed by right to build in this zoning code would be 3.5 times 10,000, which means we're going to have a 35,000 square foot potential building. So simple and straightforward. That's telling us how big this building is going to be. Now, could somebody build a 30,000 or 25,000 square foot building? Absolutely. People do it all the time. You don't necessarily always max out the zoning capacity. Would they build a 5,000 square foot building? Probably not, right? At some point, if your desire is to build a 5,000 square foot building and you have an FAR that can let you build a 35,000 square foot building, that probably means you're building the wrong building there. It probably means it's not the highest and best use and doesn't really make sense from a financial standpoint. You know, it's the client's choice, I guess, but you would probably be advising them of that. So, okay, overall size, 35,000 square feet is our maximum. Second part of the question is, how many floors is it? So we look back at FAR is 3.5. That tells us nothing about floors. All we know is that we are allowed to build that many square feet, 35,000 square feet on that site. That could mean, as long as our site, if we had the setbacks and the parking and whatever else we needed, let's say we could build 5,000 square feet easily on a footprint, well, then we could have 7 floors. 7 times 5 would be 35,000. If we figured out a way to squeeze the parking in and we had more space per on the footprint, and we could raise that number from 5,000 up towards maybe 9,000, well, then if we could do that, then we could do this in 4 floors, and we wouldn't be able to build any floors beyond that because we would have maxed out our FAR number. So the whole thing here is that the height of the building is adjusted to the footprint of the building on the site. And that's the way that they're controlling massing. And if you think about it, it makes sense, right? If this is our site and we have a 4-story building that is taking up most of the site, and we have buildings next door, and we're sort of worried about making sure that they don't get no fresh air and no sunlight and things. Well, so I have this 4-story building, it's gonna project a big shadow. That shadow is gonna be limited because it's only 4 stories. Well, now if we do the same thing again, and we think of it as a 7-story building, where that 7-story building is 5,000 square feet instead of that 9,000 square feet per, well, that's gonna be a much smaller building. So yeah, it's taller and it's going to cast a bigger shadow, but now that bigger shadow is coming from a smaller footprint of the building, and so I'm not affecting the buildings around. So in both scenarios, we're controlling how much effect the building of a large building in this site would be. And then, you know, the air can flow easily around, even though it's a 7-story building. It's a pretty big building. So this other building, which is a 4-story building, it's relatively low. It's not taking up a sort of massive, tall aspect of the neighborhood. So air is able to kind of get around relatively easy. It's a relatively short shadow. but it takes up more of the site. So that's the balance that you're trying to get out of the FAR. The FAR is all about controlling that sort of general massing, and by sort of side effect, it ends up controlling the height that's allowed, but it's never going to say, you know, FAR is 3.5, therefore you have a 7-story maximum or anything like that, right? That's not the way that the FAR works. Okay, number 2, you have been asked to work on a Frank Lloyd Wright house. As a conscientious architect, you immediately go to the building code to review any issues that might come up. And trust me, if you're working on a Frank Lloyd Wright house, there's going to be a bunch of issues that are going to come up. Stair riser heights and things like that are always kind of a mess on those buildings. They're beautiful, but they're always kind of a mess. So you're going to go to the building code, you're going to check out all the issues you should know before you get into it. What else should you check into? Well, what this is sort of clearly implying is the Frank Lloyd Wright house. So that means this is a historical structure, and you can't just start doing any changes to this building. You would have to understand, well, what kind of historical structure? Is it registered? If it's Frank Lloyd Wright, probably is. So it falls into a certain set of categories where you would actually, before you could do any permitting, you would have to be accepted through the whatever historical review that location had. And that is likely to be a much stronger control and impact of what's possible in that project than any of the other zoning or building codes. Just by sheer nature, that this is something like you're not even going to be allowed to change certain things. So one sort of example on this type of project, one of the things that happened in a sort of massive way in the 60s, 70s, and into the 80s was as people were kind of fixing older buildings up, they were thinking, well, we should really go in and make sure we use all the current new technology in order to make these things last even longer. And one famous one was Portland-based cement for the mortar on the masonry. That was sort of the current code required cements and mortars, and if you're doing a brand new building, that's what you would be expected to use. And it's a very strong material, and it kind of fits to all the kind of current thinking especially when you're using the masonry in compatibility with CMU block. But what it started to do to all the historical buildings was that the cement was so much stronger than those older bricks that as the expansion and contraction and the porous nature of the bricks, these things would happen, that expansion and contraction started spalling all the old historic bricks. So this is one of those examples where people were using the sort of standard code for the historical structures, and in that process, we're actually destroying the historical structures accidentally, not on purpose. People meant to be saving them, but in fact were doing work that ended up destroying them. So that's why this is like, before they let you do anything, they want you to go through that historical review, because they want to make sure that you're picking up all of those very specific issues that would happen for a building of that vintage.